My name is Navjot, and I'm a technical trainer based in Sydney, Australia. The topic we will be discussing is security, which is an important topic for all customers. Today, we will show you the best practices on how to create secure environments by utilizing AWS security services. We will also be learning about the AWS Shared Responsibility Model. You can access these services directly through the console, CLI, SDK, or APIs. The first aspect of security we will focus on is securing your infrastructure. Security is a top priority in AWS. The AWS infrastructure has been architected to be one of the most flexible and secure cloud computing environments available today. It is designed to provide a scalable, highly reliable platform that enables customers to deploy applications and data quickly and securely. The security services AWS offers allows customers to monitor their environment and allow security issues to be rectified in an automated manner by utilizing API integration services. Services such as AWS Config can monitor AWS resources to track configuration changes and can automatically remediate its findings to improve upon the security posture of your environment. For example, if an administrator allows SSH to the world in a security group, AWS Config can remediate this automatically. The platform itself has been built with high availability in mind to eliminate single points of failure. The AWS Global Infrastructure is highly accredited, and we discuss later in this module the industry standard compliance program AWS is compliant with. Examining the AWS cloud, you will see that the same security isolations are employed as you would be able to find in a traditional data center. These include physical data center security separation of the network, isolation of the server hardware, and isolation of the storage. We have a shared responsibility model with the customer. AWS manages and controls the component from the host operating system and virtualization layer down to the physical security of the facilities in which these services operate. This is what we call security of the cloud. In the previous slide, we talked about how AWS is responsible for security of the cloud. The customer is responsible for security in the cloud. What this means is AWS customers are responsible for building secure applications. We provide a wide variety of best practice documents, encryption tools, and other guidance our customer can leverage in delivering an application-level security measures. In addition, AWS partners offer hundreds of tools and features to help customers to meet their security objectives, ranging from network security, configuration management, access control, and data encryption. For example, if a customer has a security requirement to implement encryption at rest on their EBS volumes, customers are responsible for configuring EBS to use KMS encryption keys to meet this requirement. If we put the two parts we have just discussed together, that is security of the cloud and security in the cloud, this forms the AWS Shared Responsibility Model. AWS operates under this model. An easy way to remember how this works is to think of it like this. Anything you cannot see, touch, or change is AWS responsibility, security of the cloud. For example, customers do not have access to open our EBS storage racks. Therefore, the physical and logical security of EBS belong to AWS under the shared responsibility model. Anything a customer can see, touch, or change is customer's area of responsibility, security in the cloud. For example, customers have full access to their EC2 instance operating system. So the customer is responsible for patching vulnerabilities within the operating system. AWS has a full suite of security services that customer can leverage in their environments. The three security services we will focus on today is AWS IAM, Identity and Access Management, Amazon Inspector, and AWS Shield. When it comes to the two A's of within AWS account, the services which manages these is IAM, which we will discuss in further detail. IAM is a service which controls who can authenticate to an AWS account. This can be done using a number of options within an IAM console. The first option is IAM users. IAM users can be created and we can authorize what actions an IAM user can perform inside the account. We can also create IAM groups and place the IAM user inside the group. We can then authorize what actions the group can perform inside the account. This removes some of the administrative burden of having to manage authorization at an individual IAM user level. The last option which can be used are IAM roles. And we can authorize what actions the IAM role can take inside the AWS account. IAM roles are unique in that they provide temporary credentials that can be used to access AWS resources. The IAM role can be assumed by IAM user, and at AWS services such as EC2 or Lambda, this means we do not need to hard code our credentials inside our application. On the EC2 instance itself, IAM roles can also be used by other AWS accounts or cross accounts access and federated identities to allow existing identities from our corporate Active Directory to access AWS resources. IAM users can access AWS via three methods. The first is AWS CLI, the command line interface, typically used by system administrators. AWS SDKs, the software development kits, typically used by developers, and the AWS Management Console, used when customers prefer to use a simple GUI. Each one of these access methods requires an IAM user to be authenticated before they can access the AWS resources. After the IAM users authenticates to AWS, how do they control what they have access to? This is done via an IAM policy. An IAM policy is a document, typically written in JSON, which determines which service and what access to those services an IAM user has. As mentioned earlier, an IAM role can be assumed by IAM users, AWS services, and other AWS accounts and federated identities. The IAM policy is assigned to an IAM role, which determines what role does or does not have access to the inside AWS account. In this scenario, the application on the EC2 instance wants to access the S3 bucket. By default, the EC2 instance has no credential to access the S3 bucket, so access is denied. First, we create an IAM policy or use a template policy to determine what we want the EC2 instance to have access to. After the policy is created, we then create an IAM role. Next, we associate the IAM role directly to the EC2 instance. After we do this, the EC2 instance can access the S3 bucket, and IAM policies determines which action EC2 instance can take on the S3 resource. Though the whole process, the EC2 instance does not have any credentials hard-coded, and the IAM role ensures the temporary credentials assigned to the EC2 instance are rotated on a regular basis. In this demo, we will visually explain the IAM concepts using a virtual blackboard. The root account is the first account created and has full access to the AWS account. We recommend the following best practices to secure the root account: enable a strong password, enable multi-factor authentication, IAM supports hardware and software tokens, and delete the root access keys. At the heart of IAM are IAM policies. There are two types of IAM policies, which are AWS managed and customer managed. An IAM policy specifies what a principal has access to or has been denied access to. IAM policies can be assigned to different principals later. One type of principal is an IAM user. An IAM user can authenticate to the AWS account in two ways: via the console using a username and password, or via access keys using the AWS SDKs or CLIs. One or more IAM policies can be applied to the user. Assigning policies directly to users can be an administrative burden. IAM also supports groups. Groups can be created based on roles users perform. Users can be added to the IAM group, and IAM policies can be assigned directly to the group rather than each user. This makes administration a lot easier. Another type of principal is an IAM role. Think of an IAM role as a hard hat that other AWS services can put on. Our EC2 instance is going to put on this hard hat or assume this role. By assuming a role, the EC2 instance is granted access as per the IAM policy assigned to the role. In this example, the IAM policy provides read and write access to the S3 bucket. Behind the scene, there is a service called STS, which powers IAM roles. This service issues temporary credentials. Rotate the temporary credentials and assign a time to live for our temporary credentials. Here is a summary of best practices we recommend when it comes to security in IAM. I have discussed some of these best practices already. I'll pick out a few to highlight. Use the principle of least privilege. Only grant enough to access for users to complete their tasks. Do not assign anything more or less. Whenever possible, use IAM roles so we don't have to hard code any credentials in our instances or in our application code. Rotate your credentials. IAM supports password policy changes, and access keys can be also recreated. Lastly, monitor activity in your account. Use services like CloudTrail to keep track of all the API calls made in your account and store them in an S3 bucket for traceability. Access your security and compliance. Performing threat assessments inside an environment is not an easy task. Most tools are costly, and configuration and maintenance takes time. Is there an AWS managed service that can assist and perform a lot of the heavy lifting for customers? Amazon Inspector can help with performing threat assessments in your AWS environment. It automatically assesses applications for vulnerabilities or deviation from best practices. After performing the analysis, inspector will produce a detailed security finding report which is accessible from the AWS Inspector console or via an API. Amazon Inspector includes a knowledge base of hundreds of rules mapped to common best practices in security. And these rules are regularly updated by AWS security researchers. Inspector leverages an agent installed inside the EC2 instance to perform the threat assessment. This makes it easy to build as a part of your DevOps deployment process. Here is an example of inspector findings after a scan. Findings are potential security threats. Each finding will contain a detailed description of the security issue and the recommendations for the resolution. Some of the details provided include name of the EC2 instance where the finding was registered, name of the template used to produce the finding, assessment start, end time, severity of the findings and remediation steps. Here's an example of a finding and remediation actions. As you can see, inspector details the finding and then provides detailed remediation actions. In this particular case, it is recommending to prevent root logins over SSH. In this section, we will discuss the AWS services which protect against distributed denial of service attacks. When a DDoS attack occurs, an attacker is trying to flood your website to cause an outage. The attacker typically uses multiple sources such as compromised computers, infected with malware from various locations around the world. The attacker can attempt to exhaust compute or bandwidth resources to your website to take it down or make it unavailable to legitimate users trying to access your website. DDoS mitigation is a complex task. It is not something that can be quickly set up on-prem. There are challenges around provisioning enough bandwidth. It may require re-architecting existing solutions and can be costly to implement and maintain. AWS Shield provides DDoS protection out of the box for customers as a managed service. The service is also on and is free when customers use services such as ELBs, CloudFront, and API Gateway. It does not require any re-architecting to existing application and leverages our highly available, secure global infrastructure. As mentioned, entire Shield standard is a free service that protects all customer provided. They are using services like ELB, CloudFront, and API Gateway. With Shield Advance, there is a cost associated, but there are a number of benefits to customers such as specialized support from a dedicated DDoS response team and cost protection. With Shield Advanced, customers have access to a DDoS response team 24/7 that can assist customers when they are under a DDoS attack. With cost protection, any cost a customer incurs due to a DDoS attack, for example scaling out, AWS will cover the cost. In the next section, we will look at assurance program that AWS is compliant with. Here is a sample of the assurance programs that AWS is compliant with. These are the industry standards, programs, and some customers may already be familiar with, such as ISO, SOC, IRAP, and furthermore. Customer can access the AWS compliance page to get further details on each program and how AWS is compliant. To assist customers achieve compliance, AWS ensures the underlying platform is compliant and provides proof of compliance via attestations, of compliance provided by third-party companies. Let's take PCI, Payment Card Industry Standard, as an example. Many AWS services are PCI compliant, but customers are responsible for making sure their application code is PCI compliant. AWS and customers shares the responsibility when it comes to compliance as well. Let's take a look at a demo for AWS compliance. Customers can navigate to the AWS Compliance Programs page to see the various programs AWS is compliant with. Scrolling through the page, there are global programs as well as country and region-specific programs. By clicking on one of the programs, we can access more information. For example, let's have a look at PCI DDS Level 1. But what if we need to provide an artifact to an auditor to prove that AWS is PCI compliant? Do we need to engage AWS to obtain the necessary evidence? This can be resolved by customers directly via the AWS console. Customers can access the AWS Artifact service. This service allows customers to download the PCI attestation compliance reports where reputable third-party companies have verified AWS is PCI compliant. This document can be provided to the auditors. Remember, AWS operates under the shared responsibility model. Customers are responsible for owning their own certifications. While AWS can assist with the infrastructure and AWS services compliance part of the equation, customers are responsible for reviewing, designing, identifying, and verifying they are compliant with their requirements. Thanks for watching Module 4. Now is probably a good time to take a quiz and check your knowledge.